Hi, my name is Ariana Bazan, and today we are going to be using advanced stoichiometry to solve the given problem. We are going to be finding the concentration of the ions and the limiting reactant. As you can see, we are mixing aluminum sulfate with barium chloride and, again, determining the final concentration of all ions. If we look in the problem, we are given 250 milliliters of aluminum sulfate and 300 milliliters of barium chloride. Now, in order to determine the final concentration of all ions, we have to find what our molecular equation is. As you can see, I have written it here. Here we have aluminum sulfide. We have to determine the cation, the cation and anion to be able to cross charges. As you can see, aluminum gave sulfite 3 and sulfite gave aluminum 2. Again, the problem is aqueous in this problem because we are given a molarity. That's how we know. And then here we have the barium chloride. Again, we cross charges, aqueous. So this problem is a double replacement problem, meaning that we will swap partners. So we go from aluminum sulfite to aluminum chloride and barium chloride to barium sulfite. And as you can see here, when we mix these, aluminum chloride is aqueous. However, barium sulfate is a solid, which means that when we solve this problem, barium sulfite will not dissociate. Now that we have our full balanced equation, we can see that 1 mole of aluminum sulfate and get with 3 barium chlorides will give us 2 aluminum chlorides and 3 barium sulfates. Now, we're finding the concentrations of all ions again, so that means that we're going to want all the ions. But how did we find this? Well, we take our molecular equation and we turn it into a total ionic. As I said, barium sulfate is the only compound in this problem that will not dissociate, which means that aluminum sulfate will turn into 2 aluminums, 3 sulfates, 3 bariums, and 6 chlorides because we have 2, 3, so it gives us 6. And again, all of these are going to be aqueous. And then we'll take aluminum chloride. We have 2, 2, 6 chlorides, chlorines, 3, 2, and again, this doesn't change, so we just bring that down. Now, everything that dissociated is aqueous. Now, if we look here, we have aluminum on both sides as well as chlorine on both sides, which means that aluminum and chlorine are our spectator ions, which means they are eliminated. So for our total net ionic equation, it's just going to be 3 bariums plus 3 sulfates to give us 3 barium sulfate solid. Again, in our problem, these are the 4 elements that we're looking for the concentration of their ions. Our first step will be finding the moles of our reactants. Now, if we look at our equation, we know that our reactants are aluminum sulfate and barium chloride, and we know we are given our measurements of the volume and molarity already for each. So using that and using our triangle, we are going to use the molarity of aluminum sulfate that we are given in our problem and the volume, and we're going to multiply it as our triangle tells us to get 0.1250 moles of aluminum sulfate. And we are going to do the same for barium chloride to give us 0.1800 moles of barium chloride. Now that we have the moles of our 2 reactants, we can go on to determining our limiting reagent. Since we have our moles of each reactant, we are going to be using this stoichiometry map of going from moles of aluminum sulfate to moles of barium chloride to find and determine what our limiting reactant truly is. Now, Using the moles of aluminum sulfate that we found from the last step, we are going to use the mole-to-mole ratio of aluminum sulfate to barium chloride, as you can see here in our balanced equation, to calculate the total moles of barium chloride, which gives us 0.3750 moles of barium chloride. Now, we have 0.18 moles of barium chloride, as we found in our last step. But as we can see from our calculations, we need 0.375 moles of barium chloride, which means barium chloride is our limiting reagent. Okay, so now that we have determined our limiting reagent as barium chloride, we now need to find the amount of our reactants and products formed to determine our final concentrations. Using our limiting reactant that we found of 0.18 moles, we are going to do that for each product and reactant. Now, using our mole-to-mole ratio of barium sulfate over barium chloride, as you can see in the balanced equation, we have 3/3, which is basically 1/1. So I just simplified it. When we calculate it, we get 0.18 moles of barium sulfate. Now, doing the same for aluminum sulfate, we can see our mole-to-mole ratio is actually different, so it's 1/3. We do the calculations, and we get 0.6 moles of aluminum sulfate. And using this, since we know our moles of aluminum sulfate that we calculated in the first step, we are going to use our initial minus our final. So 0.125 minus 0.6 that we found right now, to give us 0.65 moles of aluminum sulfate. And then for our last product of aluminum chloride, we use the mole-to-mole ratio again, so it's going to be 2/3, to give us 0.12 moles of aluminum chloride. Okay, so my marker's acting up, so I'm switching to paper. But here, now the final step is to use all of what we found to find our final concentration. Now, this is usually something done in the first step, but I did forget to include it. But you need to calculate the total volume that you are given. So as you can see in our problem, we were given 250 milliliters of aluminum sulfate and 300 of barium chloride. So adding those together, we see that we get 550 milliliters, or equal to 0.55 liters. So using this, we are going to calculate our volumes. As we know, we had 0.12 moles of aluminum sulfate. Just scratch it out. We're going to divide that by our volume. We know that molarity is equal to moles of the solute over volume of the solution, and that will give us 0.218 molarity, or moles of, or concentration of aluminum. Now, using our mole-to-mole ratio of, we can see that we have 3 sulfates in aluminum sulfate. We are going to do our moles of aluminum sulfate times our mole-to-mole ratio to get 0.195 moles of sulfate. Then using that, we are going to divide it by our volume, and that's going to give us 0.3545 molarity of sulfate. Doing that again to find our chlorine, we are going to do 0.12 moles of aluminum chlorine, and using our mole-to-mole ratio, we have 3 moles in aluminum chlorine, or 3 moles of chlorine, to give us 0.36 moles of chlorine, and then we're going to divide that by our volume to give us 0.6545 concentration of chlorine. So also going back to our barium chloride, we know that that was our limiting reactant. So for our barium, we know that all of it was used, right? Because it was our limiting. So we did not have enough for the reaction that we actually needed. So the concentration is going to be 0 because it was all used up. There's nothing left over. And here we have our concentrations of each ion in our problem. We have of aluminum, sulfate, chlorine, and barium. Thank you. I hope this problem was easy to understand, and using stoichiometry actually makes this problem a lot simpler. And it's not as complicated as it may seem despite being called advanced. It just is a little time consuming, but once you get the hang of it, it is pretty simple. Thank you.